All right. I see folks moseying on in. Thanks for choosing Redox. I know you guys have a lot of choices here today. Really interesting to see some of the familiar faces in the room. I tell you what, there's a lot of different things out here in the marketplace today that we get a chance to see. There's some what I call noise in the marketplace. We start as producers to look at the economics, the agronomics, the logistics of what we're putting inside of our businesses. How do we get better at what we do? How do we get better at what we do every day? I would challenge you here, as you're learning and growing, to work with companies that can teach and help and educate you within your operation. It's a huge piece of the puzzle, right? So I've done it all my career. So my name's Chad Siebold. I hail from the beautiful state of Nebraska. A little bit of snow on the ground. I see some Nebraskans out there. I serve as the Vice President of Sales for basically row crop division. We're lucky enough here to have John Kelly with us. John is the corporate agronomist for Redox Bio-Nutrients. One of the things that John does better than most is educate. So if you slept through chemistry class, I want you to wake up. It's going to be high level, but it's going to be understandable. John does some of the best work in the business. John Kelly is out of Burley, Idaho. He's got a great looking haircut. Please join me and welcome John Kelly.
Well, I'm glad to be here at Commodity Classic and in this seminar, and hope that it will be beneficial. What I'd like to talk about is nitrogen, and the title of the presentation is From Feeding the Planet to Protecting Our Future. Let's start with the fundamentals. Fundamentals is we're surrounded by nitrogen, literally. 78% of the air we breathe is nitrogen, yet is not in the form that a plant can utilize. Fortunately, back in 1913, two German scientists, Karl Bosch and Fritz Haber, they developed a process for converting nitrogen in the air to anhydrous ammonia called the Haber-Bosch process. Unfortunately, from 1913 through the 1950s, most of this technology was not used for agriculture, for fertilizer. It was used for munitions. But let's look back on historically what happened. From the time data started to be collected looking at corn, the United States maintained a consistent 26 bushel per acre average yield. So going way back into the mid-1800s up through 1950. Then things started to change. The first thing, of course, was improved genetics. But also, what began to occur in the market is widespread adoption of conventional or synthetic nitrogen use. So as we see the trends over the years from the 1950s until today, yields in corn have increased by about 7 times. So genetics and modern fertilizer. We refer to this as the green revolution, which has literally resulted in feeding the planet. So fantastic. Where are we at now? Well, our challenges. Nitrogen production is a global affair. As we look at, in darker blue, the net exporters versus importers, you see where the United States is at. We are a net importer of nitrogen, conventional nitrogen. That used to not be the case. Nitrogen production facilities decades ago that were close to ports could not compete with cheaper imports and shuttered permanently. So it puts us in a position that we are reliant to a certain extent on imports. In fact, today the United States only produces about 12% of global nitrogen production. Another challenge, of course, is the environment. So when we look at statistics, they attribute about 2/3 of the greenhouse gas production of nitrogen at the farm level, about a third to the production of those inputs. And likewise, what we know is in the various states of nitrogen from application to uptake in the plant, it can volatilize and also can leach. So as we know, groundwater contamination of nitrate and nitrogen, of course, is also a concern. This, of course, does not paint a great picture in the media. In fact, headlines like this research, excess fertilizer use, which countries are the worst? Well, the United States is not the worst, but we're not the best either. There's definitely room for improvement. And also headlines of only 2/3 of the nitrogen produced is actually getting into the crop. It also does not play well. It even gets into even National Geographic saying things like, if you don't watch out, agriculture is going to destroy the planet. Yet if you dive deeper in this same article, it says things like, well, without nitrogen fertilizer, half the planet wouldn't be alive. So we have this tremendous paradox. We've made huge progress, yet we have challenges in front of us. So with this backdrop, let's talk about some of the solutions for nitrogen. And I would suggest that there are three key areas for solutions. The first being chemical, the second being soil health, and the third being plant physiology itself, or the crops we deal with. The chemical, the focus of the chemical solutions are to prevent or inhibit losses to the atmosphere or to the groundwater. Because no matter what source of nitrogen is applied, it is subject to both chemical and biochemical processes in the soil and the soil surface that create gaseous forms as well as leachable forms of nitrogen. So among the solutions in this chemical category are nitrification inhibitors, very common in the marketplace, urease inhibitors, slow release tools, and perhaps most important, best management practices for nitrogen, which involved rates and timing to limit exposure to losses and with more of a focus of getting nitrogen into the plant. These chemical solutions are well in play and widely used, which is great because it is well documented. It does have an impact on nitrogen efficiency. The second category of soil health has a lot of upside potential. And I would suggest there are three keys which we're not going to spend much time on, although I would love to spend the next 20 minutes talking about soil health. But if we address basic soil chemistry, plant physiology or root development, the corresponding biology tends to be a response to that. And what we see day in, day out is it is not difficult to achieve about 25% increases in efficiency of nitrogen use and utilization by the crop simply by a focus on soil health. And we are very enthusiastic about these. These make a lot of sense, and there's a lot of opportunity in the soil health arena. The third category of plant physiology, I would suggest, is the next frontier. This is the area focusing on the plant itself is where we can achieve very, very significant increases in improved efficiency with nitrogen inputs. So that's where I'm going to spend the next few minutes talking. And let's start with the beginning to paint the picture of why the plant itself and plant physiology is the next frontier. What are the resources used in building our crops? It is sunlight, energy, water, and air, specifically the carbon dioxide in the air. It is amazing because when we step back and look at what a plant is made of, It is made of carbon, hydrogen, and oxygen primarily. In fact, 95% of plant composition is what nature gives us. So the result of sunlight energy, photosynthesis, carbon dioxide, and water, that's what makes a plant. It is humbling for us in the industry to realize when we fertilize, when we are looking to tweak the system in our favor, we're just working with nature because nature does the bulk of the work. In fact, just to illustrate just how hard a plant works in this process, let's take the example of a 200 bushel corn crop in an acre. And we talk about respiration, where that plant is taking in air in order to build these molecules in the plant. Literally, an acre of corn at 200 bushels has to take in over 8,600 cubic feet of air to build that plant. So visualize that. If now multiply that by 1,000 acres, just how much air has to pass through that plant in order to afford the resources for that production. To visualize that, if we took the Dallas Cowboys Stadium, the air inside that, multiply that by 3.6 times, and that's how much air has to pass through 1 acre of corn. A lot of work being done there by nature. Okay, let's revisit the process of photosynthesis, because I want to illustrate right off the bat what happens inside of a plant. There is a reaction, in fact, is the most common reaction on planet Earth, called a redox reaction. A redox reaction is one in where electrons are either donated or taken in. And so right as in the process of photosynthesis, this redox reaction is creating electrical charge. In fact, it turns out that charge and chemistry and biochemistry are all in one. And the concept of plant charge balance is essential to crop performance. In fact, plants must maintain an equilibrium, a perfect equilibrium of 50% positively charged ions and 50% negatively charged ions. And of course, our fertilizer brings a charge. Well, when it comes to the negative charge inside of a plant, about 80% of that comes from nitrate nitrogen. And we're going to talk about why that's critical. Inside the plant and in the soil and in the plant process, there are production of compounds that we refer to as redox active molecules. And what they do is they help regulate internally in the plant the flow of energy and help maintain this charge. And these molecules, they help optimize nutrient uptake, stabilize the internal environment in the plant, minimize the level of oxidants in the plant. So they provide an antioxidant response. So they play a key function in the plants of maintaining the relative balance. All right, with that in mind, now let's go back to our discussion of nitrogen and opportunities. Well, because of soil microbial activity, no matter what form of nitrogen is applied to the soil, a process called nitrification occurs. Wherein Nitrosomonas nitrobacter converts nitrogen ultimately to nitrate nitrogen, but in the nitrification process, it's in a gaseous form and ultimately results in nitrate nitrogen with a negative charge. Because the soil has a negative charge, that's why nitrate nitrogen is highly susceptible to leaching. Well, the good thing about nitrate nitrogen is because up until the 50s, plants evolved without synthetic nitrogen. They've developed very great capabilities at taking up nitrate nitrogen. Let's talk about nitrate and nitrogen. Easily taken up. However, it becomes stored in the vacuole of the cell. Now here is, I'm going to talk about the next 30 seconds, the key opportunity for nitrogen in harnessing the potential of plants. Plants can take up and store nitrate and nitrogen. They can't use it, not in that form. It must go through a reduction process, okay? And this reduction process is energy intensive. It is carbon intensive, okay? This is what holds the plant back from applying more and more and more nitrogen and increasing yields. What we want nitrogen to become is through the reduction process to become a component of amino acids, which are made of carbon, hydrogen, oxygen, and nitrogen, okay? And those are the building block of life. Once nitrogen internally in the plant becomes an amino acid, there is no end to the benefit of nitrogen at that point in the plant. Okay, so that is the challenge. We can get nitrogen into the plant, but we've got to get this conversion process accomplished in a very efficient manner with the least amount of energy. So we defined excess nitrogen in plants as a plant that has too much nitrogen in the vacuole and not enough amino acids. And I'm going to reference research related to the impact of excess nitrogen or the accumulation of this nitrate nitrogen in plants. First, it actually can be toxic to the plant, and you'll see I will cite some of the research related to this. Second, it literally stunts root growth, okay? And that is research we as well have found is a plant high in nitrate nitrogen accumulated, it does limit root growth. There's a fundamentally an energy imbalance. It burns ATP just to manage nitrogen. So that plant literally it's again, that nitrate nitrogen, negative electrical charge, is a plant highly oxidized. So that plant has to allocate a lot of the energy potential just to balance itself. This you may not be aware of. It literally reduces phosphorus and potassium uptake in the plant. Potassium, it turns out, is the key counter ion to accumulation of the negative electrical charge of nitrate and nitrogen. Potassium with its positive charge. A plant will allocate up to 40% of all of its cellular energy just to maintaining potassium ion channels to help the plant pull up more potassium to balance itself, okay? So when we have too much nitrogen, poor stomatal control, low stress tolerance, it's literally creating stress in that plant. Then the next reference is high affinity for transport is suppressed. What does that mean? It literally makes the plant lazy, okay? They become reliant on that constant feeding. And then, last but not least, or second to the last, is reduced photosynthesis. And this sometimes can be challenging. Sometimes the visual look of a plant with a dark green with nitrate nitrogen accumulation might look great, but it's actually not the healthiest plant. And then the last thing is reduced protein and sugar content, which of course is what the outcome of what we're trying to produce. So in summary, if I haven't made the case so far, this excess nitrate nitrogen accumulation in the vacuole of the cells is a major stress point, okay? And it has a negative outcome, and so it creates inherently a challenge in the marketplace. Well, I'd like to emphasize, the problem is not nitrogen. It's nitrogen without balance. That is the challenge, okay? So I come back to plant physiology, if we really want to make enormous strides in nitrogen optimization, we have to focus on how the plant functions and how we can encourage nitrogen optimization. So again, the Redox active molecule technology, or RAM technology, which is in Redox products, helps maintain a balance of positive negative charge in the plant so the plant can allocate more energy to nitrogen optimization. So it's really about optimizing energy within the plants. That's the purpose of our technology. Now, I will give you a little background on Redox, what we do, what our technology is about. We are just over 30 years in business. We are an ISO 9001 certified company, which is a third-party certification for quality and performance. And we have a number of patents and trademarks. But when you look at our technology, what does it involve? Well, I'm listing up here these Redox active molecules. Some will be a familiar to you, some will be unique, but these are technologies we employ in our products to help plants achieve this balance wherein they can allocate energy to yield and quality. As a company, we focus on 4 areas: abiotic stress defense, which are the non-living factors which influence crop performance, soil health, root development, and nutrient optimization. There is one product I would like to discuss, and it is called RDX-N. And RDX-N is proving to be a very, very valuable tool in our quest to improve better nitrogen optimization in crops. What it is, it's a patent botanical extract. It activates metabolic pathways that are natural in the plant, but turns them on faster and stronger, and influence gene expression, which helps plants utilize the nitrogen that gets in the plant more efficiently. Plant active botanical extracts, natural signaling processes, supports consistent season-long nitrogen application, and some of the benefits of RDX-N are of course financial. Logistically, we're seeing very significant improvements in efficiency. In the marketplace, where we've done significant third-party testing, our norm is to take grower standard and cut nitrogen in half and look at performance to see if we can maintain or increase yield. In practice, it's probably somewhere between 25 and 50%, with some growers that are not changing at all, just looking how that impacts their crop. And this of course has an immediate play for financial as well as environmental concerns, is when your net load into the environment, into the crop, is dramatically reduced. That has a lot of upside potential. And then the great thing about this RDX-N technology is it's easy to use. In season, and we're referencing from planting in season, typically we're applying this in conjunction with or complement to in-season nitrogen. So very, very easy to use. And our use rate per crop cycle is between 1 pint and a quart per acre. With that, I'm gonna turn the mic over back to Chad and let him discuss just a quick overview of what we're seeing in the marketplace.
Thanks, John. Do you guys see why I pull off the mic and let the intelligent man talk? How many times have you sat through a meeting and 80%, 90% of the way through the meeting, no products talked about, right? So I'm the sales guy. I'm gonna tell you, results this season with RDX-N, pretty phenomenal. We looked at grower standards. If you take your existing nitrogen program, adding RDX-N here, out of all of our trials at a 0.9 NUE, had about an 8 bushel lift reducing. When I say NUE, I think everybody kind of gets that. You guys have been around it a while. It's the number of pounds of nitrogen used per bushel. Make sense? Next slide. For the folks that did reduce this year, right? For the folks that did reduce, we had an average reduction of 38 pounds and just over a 4.5 bushel lift by adding a pint, 16 ounce RDX-N and reducing nitrogen. What do you think happens in that? What's cost 32 right now? We talked about the economics, the agronomics, right? It all starts to make sense. John does a really good job of education. Hopefully you guys learned at least a little bit about the backside of what nitrogen or an abundance of nitrogen can do. I'd like for you to stop by the booth 4107. We can talk more about how and what we can do, but I do want to leave the last couple minutes for questions, Aim. Any questions?
I think we have a grand total of 3 minutes left is all, but okay.
I do see some familiar faces in the room. For the ones that are working with us this year, here's what we like, right? You have to have an open mind. When you start thinking about the way that we've done it forever, right? Nobody wants to admit it. On our farm in Southwest Iowa, we've seen over a period of time, you showed it, right? Production values have went up at what cost, right? What we are doing today, and I will talk about this till I'm blue in the face. We over apply. We have an environment where that plant has an abundance of nitrogen, and we as producers are causing that stress. You have to offset that stress. Anybody hit ceilings on their operations based off NPK application? Everybody, right? There's only so much you can do with NPK. The next chapter is here. Stop by and see us at Redox Bio-Nutrients, 4107. Oh, we got one question. Go ahead.
Am I on? No, just a little. Jared tried RDX-N in Central Illinois last year, right, Jared? I put him on the spot. What did you do?
So I'm here. I mean, part of this is because of RDX-N probably. So I ended up getting third nationally in the nitrogen management class of the NCGA yield contest. I was trying to win the strip till class originally, and I had about 330 pounds of nitrogen on, and we were shooting for 350 bushels. And I yielded 293. Where I used RDX-N, I had 168 pounds on and had 308. So significantly more profitable when I look at reducing nitrogen there. So we're going to try a ton of it on farm next year. And I've got a lot of growers in my area. They're going to be using it too because we're looking at input prices and nitrogen's getting pretty expensive. So it's a very interesting product.
Thanks, Jared. That's Central Illinois, good dirt, no irrigation like we have in Nebraska, Johnny. We got one more question here.
I understand you can't apply this with anhydrous ammonia?
The question, go ahead.
On anhydrous, yeah, no, you can't apply with anhydrous. What you would do in that situation, it depends on how reliant on you are on your anhydrous, you would probably just start in furrow and put some RDX-N in furrow and just let the residual nitrogen as that releases.
Can I just add, if you come to our booth, we do have an anhydrous trial that we did in Indiana last year. He actually made a separate pass. I will put that as a caveat, but came in the next day. I think it was June 14th. Happy to go over the results with you.
Great question. Thanks, you guys. Appreciate it. Stop by the booth. Thanks for your time.